Hi guys, today we're going to do our mini lesson on electrical. This should be pretty straightforward and probably easy for most of you because we have done electrical, I think, in all of our classes so far. We're going to look at injuries first, then we'll move on to hazards, and then we'll look at some of the OSHA requirements with like electrical devices. So it's important to know that there are four basic types of injuries. One is electrocution, that's when you die from an electric shock itself. Then burns, usually received where it enters and exits your body. And then falls, when you get a shock, usually if you're up on a ladder or up off the ground. On average, somebody is electrocuted on the job every day. This was way worse before OSHA came into being, but people do still get electrocuted all too frequently. Some basic terminology. Remember that current, that's the movement of the electric charge or the flow, and that is measured in amps. Resistance is the opposition to that flow of current. Voltage is the pressure or the force behind it. Conductors offer little or no resistance to the flow of electricity. Metal, water are some common ones. And then insulators offer high resistance to the flow of electricity. So wood, glass, bakelite, rubber, these are all good insulators. And then grounding, remember that that is a conductive connection to earth, okay, or the ground that we stand on. Remember that electricity is always trying to seek ground. So you have to give it an easier path to take so that you don't become the path to ground. So electric shock, it's received when current passes through your body. The severity of it is going to depend on the path it takes, how long you're in contact with it, and how much current is actually flowing through you. We tend to stand on our feet and we tend to grab things with our hands. So those are usually the common points. So if you are standing on something that's grounded and you touched a wire, that electricity is going to flow through your hand, down your arm, your torso, down your leg, and out your foot. So you're going to be in contact with it for a while. It's got quite a long path through your body. And the heart is what we're really worried about. We're going to see that in just a moment. Okay. And just because something is low voltage, it doesn't mean that the hazard is not there. So when you have a current, basically 1/10 of an amp, okay, at least 1/10 of an amp is possible to cause death. And it's going to cause ventricular fibrillation. It basically gives you a rapid or ineffective heartbeat. It's going to require the use of an AED to be able to correct that if it's going to be able to be corrected. 1/10 of an amp is a very small amount. In most any tool that we use, or coffee makers, or anything electrical that we tend to use, is going to be much, much higher than that. So there's something called potential difference. Okay, if you think of voltage, you've got one wire that's at 120 volts and another wire that is at 0 volts. That's a potential difference of 120. So if you come in contact with both of those wires, they want to even out. So that current will end up flowing through you. So if you think of a wire that's got 120 volts in it, and you're standing on the ground, which has no voltage in it, and you come in contact with both of those, the potential difference is 120 volts. It's going to flow through you. So if you're in contact with an energized wire, okay, or any electrical component, and you touch that ground, you're going to get a shock. It can also happen if you're not touching the ground, again, between two different wires. It will want to pass through you if there is a difference. Electrical burns, this is very common. Typically they're non-fatal, although they can be bad enough that they could be fatal. Again, they're going to occur typically where you touch the energized device and where the electricity exits your body. Again, typically a foot. But if you're touching two different things with your hands and the potential differences there, they'll both probably be in your hands. Keep in mind, this is going to be also baking the inside of the hand as well, okay, wherever that current is flowing. And then falls, working on ladders, mezzanines, anytime you're off the ground, you're up above it. If you get a shock, you lose muscle control, so it's very possible that you could end up falling, and then could be a severe injury, or it could cause death because of the fall. Maybe you survived the shock, but you died from the fall. Okay, so those are the four major injuries: electrocution, electric shock, burns, and falls. Now we're going to move on to some hazards with electricity, electrical devices, and the first one is wiring. The wire has to be big enough to be able to carry the current that is required. Okay, typically a 12 gauge wire is only meant to carry 20 amps. A 14 gauge wire is only meant to carry 15 amps. So when it comes to American Wire Gauge, AWG, the higher the number, the smaller the diameter of the wire. Okay, and you guys have dealt with gauges and other things before. It's the same idea. So the higher the number, the smaller the wire. Wiring gauge has to be matched with the potential amperage that you're trying to draw, okay, the potential flow of current. So if something is too small and you're trying to draw more amperage, that's going to create heat. And heat is a very important indicator to something being wrong. So if a tool is getting really warm, a plug, a cord, a wire, if that's getting really, really warm, then that means it's probably too small for the amount of current that you're trying to pull through it. So these have to be matched correctly. Overloading. So if you plug too many things into one device, if you take a duplex, which is 2 outlets, and you put one of those multipliers on it that gives you 6 outlets, or you plug in a power strip, you have to be careful because you've allowed for the potential of drawing too much current. You actually have to do a little bit of math. See what you're plugging in, add up what the total draw is going to be, and make sure you're less than what that one device could give you. Again, if you're drawing too much, you're going to get heat. With the heat, you can start to melt insulation. You can start have arcing happening, okay? And this is probably going to cause a fire. There are protective devices, GFCIs, fuses, circuit breakers, okay? These are all meant to protect the equipment, although GFCIs are also meant to protect people. So fuses and circuit breakers are protecting from overcurrent. If your wiring is designed to handle 15 amps, the breaker or the fuse should be a 15 amp breaker or fuse. That way, if you try to draw more, it will either trip or melt, and you're not going to damage all of the wiring downstream of it. So if you're trying to draw too much current, something's going to melt. A fuse, if that's what you're using, or circuit breakers will start tripping. So if this is constantly happening, something is wrong and you should look into it. Ground fault circuit interrupters, GFCIs, these are meant to protect people, okay? It will sense a potential difference there or a leakage to ground, and it will trip it. Supposedly this will happen below the threshold of pain, but I wouldn't test it if I were you. Grounding hazards are pretty frequently cited as violations with OSHA. Remember, everything has to be grounded. You want to give it a path. You want to give electricity a path to take in case something else goes wrong. Okay? If you're holding on to tools and there is an electrical leak in there, remember, you lose muscle control. Usually you're going to lock onto it. So that means you lock onto the tool and you can't let go of it. Overhead power lines. Many people don't know that most overhead lines are not insulated. They're almost never insulated. Usually the line that would go to a building is, but you can't even rely on that because it can get stretched or weather cracked. Okay, so you always want to stay away from those top lines. Typically, the very top line is the hot wire. If there are three, like on this pole that you see in the picture, that's for three-phase power. So all three of those are going to be hot. Typically, the next one down is going to be the neutral, which is tied to ground. And usually below that is all utility lines, data, cable, telephone, that type of stuff. Obviously, don't use metal ladders around overhead power lines, not even the ones that are insulated going to your home. And scaffolding you have to be careful with as well. So let's look at some of the electrical requirements with OSHA. These are kind of the do's and don'ts. So grounding. This is, excuse me, actually a picture of an electrical plug. It's not damaged to his thumb. You see the two prongs on the top, and then on the bottom would be the third one. This would be the ground pin. In this case, it's broken or it was taken away. So if that is missing, you don't have the path to ground. It's been interrupted. So if you plug in a power tool that relies on that, and you have an electrical leak in the tool, now you're going to have a problem. Okay, so that's a no-no. Has to be replaced. Handheld power tools. Again, I already said you're holding it in your hand. Okay, you got a really good chance, if there is a problem, of getting a severe burn or actually hanging on to it. You can't let go of it. And now you've increased the duration that you're in contact with that circuit. Okay, so handheld power tools will either be double insulated or they're going to have a three-prong plug. Any live parts have to be guarded, usually by a fence. If they're above 8 feet above a working surface, typically they're not going to be guarded. Okay. This is a picture of conduit. It's where the wiring runs down through metal conduit. When you see physical damage like that, it's severed or bent, that could actually be cutting into the insulation of the wires inside, and those could actually be energized right now. Okay, that has to be taken care of. Any sort of boxes, the knockout plugs, those can't be missing. They can actually put a plug in there. Cover plates have to be installed. Wiring cannot be hanging out of the electrical devices. Flexible cords, so think extension cords. You can't run them through window sashes or through door jambs because the opening and the closing or the chafing is most likely going to damage it, cut into it. Also an issue here with this electrical panel, it's open, it's outside, it looks like, it's open to the weather, and you have wiring hanging out. Okay, that means that the protective cover on the inside is not there, so somebody could just touch that and probably have a severe burn or electrocution. So sometimes you can use flexible cords with stationary equipment here on the right. Okay, if it's going to be plugged to maybe facilitate being moved or maintenance. Movable equipment, you have to use flexible cords with movable equipment. I mean, think of a handheld drill. That's not a solid wire. It's a flexible cord because you're moving it around. And if you're going to be hanging things, so like pendant fixtures or lighting, if it's going to be allowed to move, it has to be a flexible cord. Places you can't use flexible cords are anytime you're going inside of walls or passing through walls. That's not allowed. You also can't use it as permanent wiring for devices. Then in that case, you would be using solid core wire or Romex, like what we used in our mock-ups. So some clues that you've got something going on, that there is actually a hazard there. I'd already said if circuit breakers are tripping, fuses keep blowing, don't just go put a bigger fuse in to fix the problem. There is a problem with overcurrent, okay? Or there's a fault to ground. If tools are getting warm, connections, cords, wires, boxes, any physical devices or mechanical devices, that's a clue that something is wrong. Remember, heat, that's going to generate more resistance, which will generate more heat. It'll snowball instead of fire. If GFCIs are constantly tripping, there might be something wrong there. you probably have a ground fault. And then physically, if a cord or a wire is frayed, you can see the bare wire, or maybe where a wire goes into a plug, you can see the inner wires coming out. That's also a problem that needs to get corrected because it's just going to get worse and it's probably going to allow you to come in contact with a bare wire. Whenever you're on the job dealing with electricity, you do have to have training if you're going to be working with electrical equipment or around it. So this is going to be looking at how to de-energize equipment before you look at it or make any sort of repairs, what type of tools you're using, make sure stuff is in good shape, um, using your best judgment. Stop, think, what is the potential problem when you're working around electrical equipment? And if it's going to be required in your situation, what PPE do you need to wear and when do you need to wear it? How do you use it? So that wraps up that mini lesson. I'll have the questions for you guys posted on the Remind app. And if you'd go through those and then again send them off to me, that would be awesome. We'll have our next mini lesson on Monday. And hopefully that one will be a little bit more interesting. Thanks, guys.